A robot does not need a broken motor to become unsafe. Sometimes, the risk starts in the setup process, a wireless connection or software configuration. In 2025, researchers disclosed UniPwn. It affected several connected robots. An attacker could gain root access and even spread to nearby robots. But the important point is not the vulnerability itself. It is what the vulnerability shows. Robots do more than process data. They move and interact with people. To prevent physical harm, they rely on safety functions. But those functions increasingly depend on data, software, sensors, AI models, and control logic. When those digital layers are compromised, safety functions can be affected. That is how cyber risk becomes safety risk. The good news is that robot makers already know how to think in terms of hazards. The next step is to extend that safety thinking with a cyber lens. Step 1. Name the physical hazard. Could the robot start unexpectedly? Enter a restricted area? Stop too late? Or fail to recognize a person nearby? Step 2. Find the safety function that prevents it. For example, speed and separation monitoring helps the robot slow down when a human is nearby. Step 3. Map what that safety function depends on. Which sensor detects the person? Which control logic decides the speed? Which AI model helps the robot understand its surroundings? Then add the cybersecurity question. What could an attacker do to the data, software, or control path this safety function depends on? If sensor data is spoofed, the robot may believe a worker is farther away than they really are. If control commands are hijacked, the robot may receive movement instructions it should never execute. If firmware is modified, safety monitoring may be weakened or disabled within the system. If the AI perception path is manipulated, the robot may fail to recognize a person or a dangerous condition. In each case, the issue does not stay in the network. It reaches the safety function. This is the cyber safety challenge the EU machinery regulation is designed to address. From January 20th, 2027, robot makers must address cyber risks that could affect safe machine behavior. For robot makers, safety and security can no longer be analyzed as separate tracks. For every safety risk, ask 3 questions. Which safety function prevents it? What does that function depend on? And how could cyber interference affect that trusted path? That is how robotics teams can begin mapping cyber risks to physical hazards. And that is where physical AI cybersecurity begins. VicOne helps robotics teams assess cyber safety risks before deployment and monitor those risks during operation. Assess before you ship. Stay resilient while you operate. VicOne. Secure physical AI for real-world safety.